Welcome to this explainer. Okay, so if you're learning Python for the very first time, there's a really good chance you've already experienced that absolute sinking feeling. You know the one, right? When your program just suddenly stops, throws this massive wall of angry red text at you, and just quits. It is incredibly intimidating. But today, we're going to completely demystify Python exception handling. We'll show you exactly how to code like a professional without ever having to fear those runtime crashes again. Think of this as your absolute beginner's guide to defensive coding.
We've got a great, unhurried roadmap ahead of us today. We're going to systematically walk through everything from how to fail gracefully when things go wrong to the high stakes of real-world enterprise software. Then, we'll dive into the try-except safety net, tackle the mandatory hotel checkout rule, and finally, wrap up with some pro-level interview secrets.
Let's kick things off by talking about when things go wrong and the critical difference between a graceful failure and a total crash.
As a beginner, it's absolutely crucial to understand that in programming, things just go wrong. All the time. It's a fact of life. It isn't actually about preventing every single error, it's all about how your software reacts to them. Let's start with a really relatable, real-world scenario. Imagine you're standing at a chai tapri in Pune. You're scanning a QR code to pay 20 rupees for your tea using your PhonePe app. You hit pay, but right at that exact split second, your mobile network suddenly drops. So what happens? Does the entire app just crash? Does your phone freeze completely and force a reboot? No, of course not. Instead of a total phone meltdown, the app opts for a graceful red screen that politely says, "Network error, payment failed. Please try again." It doesn't panic. It communicates.
And you know what? That polite, graceful recovery screen is exactly what we call exception handling in programming. It's the deliberate process of catching unexpected errors. Think missing files, a dropped internet connection, or even a user typing out a word when you specifically asked for a number. It catches these anomalies to allow graceful recovery, which keeps the system alive instead of just succumbing to a hard crash.
Now let's look at how this builds into the professional landscape, because the stakes in the real world are incredibly high. Enterprise software needs serious safety guardrails.
To really appreciate the solution here, we have to look at the problem. What actually happens if you don't write defensive code? Well, the default Python behavior is remarkably dramatic. When Python hits an unexpected error, what we call an exception, its default reaction is just pure panic. It prints a massive, scary red error trace all over your terminal, and then it immediately kills the program. Game over. Now, for a beginner writing a tiny script on a laptop, that's just annoying. But out there in the real world, it's a total catastrophe.
In enterprise software, a single unhandled exception can quite literally take down an entire web server. Boom, done. And when that server goes down, nobody can check out of their shopping cart, nobody can log in, and the whole business just grinds to a halt. This results in companies losing thousands of rupees in lost sales in a matter of minutes. So as a professional developer, a massive part of your day-to-day job is making absolutely sure your code never triggers that default panic mode. And that brings us to our primary tool for catching errors before they crash the system, the try-except safety net.
So, how exactly do we prevent those horribly expensive server crashes? We use a programming safety harness known as the try and except block. Think of this like putting your risky code, say a block of code that's downloading a file from the internet, inside a literal safety harness. That's your try block. If it works, fantastic. But if an error occurs, Python doesn't just crash and burn. Instead, the except block steps in as your backup plan. Python smoothly hands control right over to this backup routine. It might just print a friendly message to the user, exactly like that payment app at the chai stall.
Okay, so we've caught the error, but what happens next? This leads us to the mandatory hotel checkout rule, also known as the finally block.
Think about what happens to the system's resources after an error is successfully caught. Let's use an analogy. Whether you had an amazing vacation or you got super sick and had to leave early, you still, finally, have to return your room keys at checkout, right? Well, the finally block in Python is that exact mandatory cleanup routine. It contains code that runs no matter what happens. Whether your try block succeeded flawlessly or it crashed and triggered the except block, that finally block is going to run, period.
In your daily coding, you'll use this finally block to return the metaphorical keys to the computer. And by returning the keys, I mean closing database connections, releasing open file handles, and freeing up system resources. Look, if you open a database to read user data, you absolutely must close it so other parts of the system can actually use it later. The finally block ensures those connections are closed securely, completely regardless of whether some random error interrupted your work halfway through.
Now that you deeply understand the mechanics, let's step into the interview spotlight and talk about how professional engineers handle this. When you're sitting across from a senior engineer for your very first junior developer job, there is a super common interview question you are almost guaranteed to face. And it's this: why is it considered bad practice to use a bare except block? Now, a bare except means you just type the word except without naming a specific error variable right next to it. To a beginner, catching all errors might sound like a brilliant idea, right? Catch everything. But to a pro, it is a massive red flag.
Here's why. A bare except indiscriminately catches literally everything. It casts a net so incredibly wide that it even stops normal system operations. For example, if you intentionally try to exit a program using Control-C, a bare except will actually block that. Even worse, it masks hidden bugs. If you simply misspell a variable name, a bare except will catch that typo, hide the error message, and leave you completely blind to the flaws in your own logic. Professional engineers always catch specific exceptions. They explicitly name the exact error they expect. And to take it a step further, they even create their own guardrails by raising custom exceptions, like an invalid balance error, to proactively halt bad data before it has a chance to corrupt the entire system.
To wrap up our explainer today, let's quickly review our 3 golden rules of defensive coding. Rule number 1, always wrap your whiskey operations in a try block. Rule number 2, always catch specific error types so you don't accidentally hide your own bugs. And rule number 3, guarantee your resource cleanup by returning those keys in the finally block. By internalizing these steps, you're making the leap from a beginner who fears the red text of a crash to an engineer who confidently directs the flow of traffic even when the road completely crumbles beneath them. So, I'll leave you with this question to ponder as you open up your code editor today. Will you let your very next unexpected error bring your whole system crashing down in a panic? Or will you catch it gracefully? Happy coding, and we'll catch you in the next explainer.